Welcome back. In this video, I want us to take another look at lists so that we can get a better understanding of how they work underneath. So the first thing we need to understand when it comes to lists is that lists are mutable. Okay? Mutable is just another way of saying that they can be changed. Alright? They are changeable. What do I mean by that? Well, first of all, let's create a list. Let's say it has the items paper and cereal, soap. Okay, that seems to be enough. So I can do something like this. I can say item 0 will be honey. Items -1 will be butter. Okay, so let's visualize this. Okay, so right away notice that unlike variables like excuse me, like ints and floats, a list will have, you can consider a list as a pointer, something that points to the actual data. Alright, so when I say items, I'm actually referring to a thing, a pointer that will direct me to the actual list. Okay, so paper is at position 0, cereal is at index 1, and soap of course is at index 2 or position 2. Now if I do item 0 is honey, notice that what I had in there before, paper, has been replaced by honey. And likewise, the last item in the list, which is now soap, will be replaced by butter. Okay, so mutable means that when you make a change to something in the list, it makes the change permanent. Okay, so that's one meaning of mutable. Now let's look at the other meaning of mutable, which is what I consider even more important. Let's say I create another list. Let's call it shopping. And I say shopping contains ice cream and jelly. Okay. Now what I'm gonna do, I will say that items is assigned shopping. Okay, so let's look let's change something. Let's say items is item 0 is a fish and shopping 0 is tuna. Okay, let's visualize. Okay, we've seen that before. Great. Okay, so on line 6 I want to create a new list. Notice I create a list called shopping, which contains ice cream and jelly. And what I'm gonna do, I will say that shopping is assigned to items. So you might be thinking that, okay, whatever shopping has, I'm going to make items have that. Okay, in other words, if shopping has ice cream and jelly, I will take those and put them in items. Alright, that seems reasonable, but let's see what actually happens. Alright, so pay attention right here. Okay, notice what happened. I went from having two pointers pointing to two separate lists to now having the two pointers pointing to a single list. So what just happened? Well, remember, the name of the variable is not the list itself. It just represents the list. Okay? So when I did items is assigned shopping, what I told Python to do was whatever shopping is pointing to, okay, I want you to not point to that thing anymore. I want you instead, okay, let me say that again. Shopping is assigned to items. So whatever shopping is pointing to, which is ice cream and jelly, I want items to also point to that same thing. So effectively what happens, items, this pointer, will be moved from honey, cereal and butter, and it will now point to ice cream jelly. Okay, so that previous list is effectively lost or dead according to Python. This doesn't exist anymore. Okay, so items and shopping now point to the same place. So if both of them are pointing or referring to the same list, it means that I could change the first item of that list to fish using the item's name or pointer. And likewise, I can change that first item to tuna by way of using shopping. Alright, so this is one era where a lot of people who are just learning to program, especially with Python, they don't understand the ramifications or the consequences of doing something like this, where you assign a list to another list. You must understand that you're not actually assigning the contents of the list. You're saying that the thing that points to the list is now pointing somewhere else. Okay, so that's what this means. And because both of them are pointing to the same place, it means you can use any one of them, either of them, to change the list. And so this is the important thing when I say that lists are mutable, meaning whatever you're doing, the changes become permanent. We don't deal with copies of the list. Okay, alright, so let's move on. So what happens if I wanted to make a copy of a list? Well, I would say something like copy items is items. Alright, we've seen this before. And so I could now go ahead and make changes to copy. Okay, so item 0 is honey. Okay, copy items -1, the last item is bread. Okay, so let's go through. We understand what's happening. So let's here make a copy. So notice I am making a copy of items. What does items currently have? Tuna and jelly. So I have a new pointer called copy items, and this list will point to tuna and jelly. It has its own copy of tuna and jelly. So if I make a change, that change only affects the copy and not the original. Okay, so remember, if you want, after your program have has finished executing, you want the original list and you want the altered list. Well, you need to make a copy of the list first and then manipulate the copy, and so you'll have both a copy and the original in case you want to refer to the original later on in your program. Okay, so this is good to make a copy because when it comes time to doing things like sorting, right? Remember, sorting will actually change the list, right? It mutates the list. So if I say something like items that sort, okay, since we have strings, it will try to sort by alphabetical order. Okay, so if we come down here, all right, let's go back. We'll see that we had tuna and jelly, and that will now become jelly and tuna because it's going from A to Z. Okay, so J comes before T. Of course, nothing happens to this list because they're two separate things. Now, what if I didn't want this original list to change? I wanted to sort the list, but I wanted the original. Well, I didn't do that. So if you ever want to keep the list unsorted, meaning you want the original list without it being sorted, but you still want it sorted, well then what you need to do is to create a new variable. So what you do, okay, you will say let's say sorted items, and what you will put in here is you're going to use the sorted function. Similar to how you can use the len function, you can use a function called sorted, which if you give it a list, it will sort that list and save that sorted list in the variable on the left hand side. Okay, so let's have a look at that. Okay. Okay. Again, we have tuna, we have jelly, and when I come here, we have a new list which now contains the sorted version of items. Okay, so the original list is the same, the sorted list is now separate. Okay, so I hope that makes sense. So the big takeaway is lists are mutable. Whatever you do to them, the change is permanent. But most importantly, if you assign one list to another, you're not actually assigning the items to the list. You're actually changing the pointer. Okay, so you're shifting the pointer, which means that if you have two variables pointing to the same list, then you can use either of them to manipulate that list. So always be careful when you are doing assignments between lists, like in line 7. Understand what you're doing. If you want to make a copy of the list to do some computation on it, then you need to make a copy. Alright, and then work on the copy. Alright, so that brings us to the end of our list section. Alright, in the next video we will look at the other equally popular, equally useful data structure, which is the dictionary. Great, I'll see you in that video.